Hello, today we are doing a problem in chapter 17, number 96 of the book Matter and Interactions, volume 2. In this problem we have a small metal sphere of radius r that has a charge q naught. A long copper wire is connected from this small sphere to a distant large uncharged metal sphere of radius r, capital R. We have to calculate the final charge q on the small sphere and the final charge capital Q of the large sphere. We are neglecting the small amount of charge on the other wire. We have to state what approximations we made. So the first step is to draw a picture. We have little r, big R connected by a wire. So conductor surfaces at equilibrium are equipotential, meaning that the potential of one surface equals the potential of another surface. So that's with the potential of the little sphere should be equal to the larger sphere. And the potential outside of a sphere is given by this formula, which is the K 1 over 4 pi epsilon naught times the charge over the radius. So that says that both of these spheres should have the same potential, so we set them equal to each other. So because of the conservation of charge, you know that Q naught has to equal the charge on one sphere plus the charge of another sphere. So that's how we get this formula, which we switch to solve for capital Q, and we get this one. This is a minus sign. So then we just plug and chug back into the original formula and solve for little q, and after solving we get this equation here, and then we put back into our other equation, this guy, and solve for capital Q, and we get this. So we assumed, in order to get capital Q and little q, we assumed that the spheres were far enough apart so that the charge distributions on the spheres were uniform, and like stated in the problem, we also said that there was no charge on the wire. We disregarded that. So that was the problem. Thanks for listening.